This is a slightly more involved axial deformation problem. It was homework 27, problem 942 from the book. So let's look at it. We have this rod thing between two walls, and it's composed of section AB and then section BC. And eventually C is going to expand because of the force and end up touching this wall D. So we're given that P is 200 kilonewtons. Displacement AC is 0.15, which is this point right here, right? This is what C will end up moving once it touches the wall. And then we have E equals 200, and our goal is to find reaction forces A and D. So A is going to be here, D is going to be here. So I just drew an overall sum of the forces, and I randomly drew in my PA and my PD. You could draw them whichever direction you prefer. As always, your negative or positive sign in your final answer is going to indicate if you drew it correctly or if it should be in the opposite direction. So I got PA plus PD equals negative 200 kilonewtons, and like we said, the displacement A to B plus displacement B to C should give you the total displacement A to C, and that is 0.15 millimeters. So this is pretty simple. We know AC, and we just have to find AB and BC. So in order to find displacement AB, I start off by looking at this section, and I just randomly cut it down the middle. And I draw in my PA and my normal force. So normal force equals negative PA. And it's really simple. I just plug this negative PA right into my equation for P. So negative PA times the length, which is 600 millimeters, over the area, which is pi over 4d squared, times E, which is just 200 gigapascals. And once you solve everything, make sure you account for the fact that this is gigapascals, so times 10 to the 9th. You end up with AB equals negative 1.527 times 10 to the negative 9 PA. So we have our unknown PA right here. Then I move to part B to C, and once again I just cut my rod right down here. I draw my PD, my normal force, and I get N equals PD. And then I just plug it back into the given equation. So because PD turned out to be positive, I plug in a positive PD times 0.6 meters times pi r squared times 200 gigapascals, and I get displacement BC equals 6.112 times 10 to the negative 9th PD. So here's our second unknown. So now what we end up with is our displacement BC, displacement AB, and we have displacement AC. So I basically plugged in AB in here, plugged in BC in here, and set that equal to 0.15 millimeters, but I just converted that into meters because that's our standard convention, standard units. So I get this equation, and as you see I have a PA and a PD, so that leaves me with two unknowns. So I go back to the original equation, which I had for the full body, of PA plus PD equals negative 200 times 10 to the third newtons, and I just plug in, rearrange this equation to get PD equal to this entire fun stuff, and I'm actually missing a PA. This PA should be right here. I apologize, guys. So anyways, I plug in this PD right down here, and that means that I am left with only one unknown, which is going to be PA. So I get PA, which right here, plus all of this stuff, I just simplified it, equals negative 200 times 10 to the third, and then I move this over to this side. I'm left with my PA, I divide through, do all that fun algebra, and I get PA equals negative 179.6 kilonewtons. This means that PA should actually be facing to the left because I originally drew it to the right. Now, I think this problem overall is not that complicated. The only part where it gets funky is all of this algebra, because you could easily mess up plugging in all of these numbers, adding, subtracting into your calculator. So like, just double checking your calculations is the biggest part, because otherwise the problem's pretty straightforward. So now that I solve for PA, I just go back to the original equation, plug in my PA right here, and I get PD equals this fun stuff, and I get finally PD equals negative 20.36 kilonewtons. And once again, I had originally drawn PD pointing to the right, but because this is negative, PD should actually be pointing to the left. And I mean, yeah, just make sure you are plugging in everything correctly into your calculator and tracking all of your numbers. Otherwise, you'll just have a calculator mistake.